Hello, algebra students. Welcome back to another video lesson today as we continue exploring solving systems, where today we're going to use substitution. If we have one equation in slope-intercept form, or can easily be modified to slope-intercept form. So here's what I want you to do for the warm-up today. Take a moment to graph this system on the coordinate plane and tell me the solution. Okay, so to graph, I'm going to open up desmos.com, go to my calculator, and we're going to graph those two lines, right? Y equals 4x plus 2. There's my first line. My second line, y equals 3x plus 1. You can see I've got red line, blue line. If I go ahead and click on the intersection point, it is labeled. And so there we have it, -1, -2. -1, -2. So we can use Desmos when we're asked to graph them. Both of these happen to be in slope-intercept form, which makes it a little easier to even graph by hand if we needed to find that intersection point. But here's my question. Is there another way to solve that problem? Could we have done it a little differently? Enter the substitution method. All right, and this is what we really kind of explored and introduced yesterday, as well as on some of your practice. In this case, both equations are equal to y. Therefore, when they both equal the same variable, I can set the other side, 4x plus 2, equal to 3x plus 1. Because y equals y, right? Y equals y is a true statement, and they both equal the y value. So we substitute 4x plus 2 into the y, 3x plus 1 into that y. And now what we really try and do is solve this part by gathering the x's, subtract 3x. We are left with x plus 2 equals 1. I subtract 2 to the other side, and x equals -1. So there's my x coordinate, -1. To find the y coordinate, we plug it back in, right? We plug it into, and you could pick the top one or you could pick the bottom one. It doesn't matter, but you're going to plug it right there for the x, because we now substitute x equals -1, where y equals 4 times -1 plus 2. 4 times -1 is -4. -4 plus 2 is -2. Y equals -2. So we get the same answer as we should from graphing. All right, and that's one way to substitute. When they both equal the same variable, we can set them equal to each other. Another form of substitute, well, I take that back. Why don't you practice on this one? Pause the video here, and then in the end, tell me what is the intersection. All right, again, they both equal y, so I can set them equal to each other so that we can gather our x's and solve for the x variable. Since that's a -5x, I'm going to add 5x to both sides. 7x plus 8. It's got to be careful over here on the right-hand side now. There is a subtraction sign in front of that 27, so that's got to come down here, making it -27. Okay, so we do have to be careful. Now I subtract 8, and 7x equals -35. When I divide both sides by 7, we get x equals -5. So there's our x coordinate, -5. We take that and we plug it back into one of those equations. I'm going to plug it into the top one. just because it was the first one listed, no other reason. 2 times negative 5 plus 8, that's negative 10 plus 8, or negative 2. Y equals negative 2. And there is our answer. Again, writing them as an ordered pair. So that's one method where they're both equal to the same variable, and we just set them equal to each other to solve. The second method is slightly different. Solve the system A plus 7B equals 49, where B equals 7 plus 8. Now, because they're not both equal to B, I could try and do that to the top, but that's a little bit more work. We know that B is equal to this expression, 7 plus A. So I can substitute that into the top equation just for this B right there, right? A plus 7B equals 49. But instead of B, we're going to replace it with what they tell us B equals. A plus 7 times, instead of B, it's 7 plus A, equals 49. And now we work on solving using the distributive property first. A plus 49 plus 7A equals 49. If I add the A values together, I get 8A plus 49 equals 49. Got to move the left one to the right-hand side. 49 minus 49 is 0. So 8A equals 0. And when I divide by 8, I get A equals 0. 0. All right, and we're going to write it as A comma B, alphabetical order. So we have A equals 0. That's called substitution. It's a second way of doing it, by taking whatever variable we have and substituting it into the other equation. If A is 0, I'm going to use this bottom equation, B equals 7 plus A, but we can substitute 7 plus 0, because we just found A was 0, or B equals 7. So their intersection point would be 0, 7. And if we not wanted to, we could certainly check this by going back to Desmos. We just have to use X and Y to check it and see if that is indeed where they intersect. So that's a second method of substitution. Okay. Now, you're going to also get story problems that refer back to using systems. We want to first define our variables, right? Don't just say X is cats or Y is dogs. Like, it represents the number of something, the number of cats, the number of dogs. And then we'll write out the equations that we have from the information. All right, so here's a story problem. The online catalog Sock Puppet will charge you $3 for shipping and handling, plus 50 cents per pair of socks that you order. The foot glove category will charge you $3.90 for shipping and handling, plus 40 cents per pair. Write a system of equations for the equation where Y is the total cost and X is the pair of socks. Y is the total cost, X is the pair of socks. So let's look at Sock Puppet, SP. Your total cost for Sock Puppet is $3 for shipping and handling, plus 50 cents per pair of sock. That's my X, plus 50 cents X. If we look at foot glove, they have different information. Their total cost Y equals $3.90 for shipping and handling, plus 40 cents per pair. So 40 cents times X. So we want to find out how many pairs of socks we would have to purchase to show that both companies would be at the same price, right? Where's that same price? Where do they intersect? Using substitution. Well, the nice part is that they both are equal to y, so we can set their expressions equal to each other. $3 plus 50 cents x equals $3.90 plus 40 cents x. Okay, so I'm going to get the x's together. I'm going to take away 40 cents x, take away the 40 cents x, and we have 3 plus 0.10x. 50 cents minus 40 cents is 10 cents. 0.10x equals $3.90. And so we subtract the 3 from both sides. 0.10x equals 0.90. When we divide, we get x equals 9. X equals 9. We would have to purchase 9 pairs of socks. 9 pairs of socks. Sorry, this is really sloppy. 9 pairs of socks would cost the same at both companies. We could figure out how much that would be if we plug that back into one of the equations. Right? The cost would equal 50 cents times 9 pairs of socks. That's $4.50 plus $3 shipping and handling would be $7.50 at both companies. All right. Story problems. Now here's the last one for today. I want you to solve this using substitution. Use substitution to solve, right? Y is this. So we're going to substitute it into that y in the opposite equation. Then I want you to check your answer by graphing. All right, you probably noticed a problem here. Minor problem. Negative 2x plus. Instead of y, the first equation is telling me y substitute with 2x plus 7. Equals 12. Notice negative 2x plus 2x turns into a 0x, right? That's just 0. So in a sense, it's going to go away. It eliminates this variable. And I'm left with something that says 7 equals 12. I don't even have a variable anymore. 7 equals 12. Well, when you graphed this, y equals 2x plus 7. And then we had 2x plus 7, negative 2x plus y. Negative 2x plus y equals 12. We got parallel lines. The lines are parallel. All right, and what did we say when 2 lines were parallel? We said no solutions. And that will happen sometimes when we are using substitution. We can get no solutions in substitution when this variable is eliminated, when the variable cancels each other out, and we get a false statement. Right, this ending statement is false. 7 does not equal 12, so it would be parallel, no solutions. All right, let me summarize this. This is really, really important, okay? Sometimes when solving systems, the variables disappear like we did in that last example. There's 2 types of answers then. We just showed this over here on the previous slide. 6 does not equal 7, 0 does not equal, right? It gives us a false statement. That's what we had here, 7 equals 12. A false statement gives us no solution. However, there are times where we may end up with 5 equals 5, 0 equals 0, 12 equals 12. We might end up with this last part without the variables being a true statement. When that happens, there are infinitely many solutions. any point up and down on that line would work as a solution. And we'll explore more of that in the next couple of days. If you have any questions about substitution and using the different methods, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.